The quadratic formula is without a doubt one of the most used formulas in mathematics. When I got it taught in school, my teacher told me, even if someone wakes you up at midnight, you should still be able to memorize it. So today I want to allocate some time and show you how we can derive this famous quadratic formula. So the quadratic formula is the general solution to this quadratic polynomial. So, and it's written in this form, which probably all of you know. The problem is, if it is written in this general form of a quadratic equation, we cannot solve it directly. But before I continue, I want to ask an important question. Why are we interested in the zeros of a quadratic equation? There are countless examples in nature where the zeros of the quadratic formulas are interesting, but I will give you one example in physics. For example, the kinematics of a projectile. The zeros are the points when the projectile will hit the ground, so they are of important value to know. So we really want to solve it in a general case. But as I said, the problem is we cannot solve it directly from here. We have to bring it in a different form. If we have it in this form, expressed by a star, b, and e, we can solve it. We have to bring a star over, then take the root, consider the plus and the minus solution, and then subtract minus b, and then we have a solution for this second form. To continue, we now have to identify the first form and the second form to each other. So if we multiply this bracket out, we get this form, and we also have to bring e over. So now we can see that a star is a, which is very simple to see. That's why I used this convention with a star. The other one will be a little bit more complicated. So this one will be b, this will be c, and now our goal is to express d and d in terms of a, b, and c. So d is b over 2a, and e is a d squared minus c. So now it's not completely done. We still have to express d squared, and I will write it here in this form. And for purposes which I will show later, I will leave the a here and not cancel it directly. So I wrote our solution that we got for our second equation here, down here. I changed a little bit the order for visual purposes. So now I can express, okay, here should be d here. I want to express d with b over 2a. And then I will change what we have here with our result that we got over there. So now we can, this is a star, which is equals to a. So we can now put in e. We can directly cancel the a that we have over here. So we get 1 over 4 a squared, b squared, and minus c over a. This is our form. Now, this expression is already correct. We just have to bring it in another form to identify it with this form. So what we will do, we will take this term and bring it out of the square root. So it will be 1 over 2a here. This one will be b squared. To do here the same, we have to add times 4a c, and now we can compare it to this form, and we exactly got our solution, so we are done. So this is how you can obtain the quadratic formula. But maybe some of you thought of a question which might occur if you think about this solution. So now we found a solution for quadratic order, but is it also possible to find it for third, fourth, fifth order, and so on? So the answer is yes and no. So for third and fourth order, we can find a solution. So it will not be as simple as this one, but at least there is a general solution. But for fifth order, there is no solution. And it's not that we just have not found it yet, it's not possible, which was proven by Galois in his work. So no matter how hard you try, you will not find a solution to that. But maybe that's part for another video. See you next time.